We can get started. And just for the introduction, I'm Uttam Ramesh. I'm the product manager for ZTNA Connector, service connections, and everything private apps and Prisma Access. And with me today is Terry. He's the technical marketing engineer for Prisma Access infrastructure. Again, we live in, just to get into the introduction part of things, we live in a world where like your applications are distributed, users are distributed, and the challenge in the modern day networking and in fact a security infrastructure is to provide a secure, low latency, high performance, and zero operational challenge connectivity for all your users to all your applications. So I think that is a big challenge in the modern present day world. And in fact, now, like at least the trend that we are observing in 2024 is that most of the users are hybrid. That is like, again, you need to have a consistent experience for a particular user who's working at home and versus working at branch, because or even working on a campus, because like 50% of the work happens in a branch and 50% maybe happens remote. So to all of those challenges, what that entails to is, well, yes, one is the multi-cloud connectivity. You have different cloud assets. Maybe like going forward, most of the enterprises, the way they work with is maybe like if GCP gives them a good deal, so they'll have some assets on Google Cloud, and because of AWS being the first player, they'll have a lot of infrastructure on AWS, and because of their EFI licensing, with they'll have some assets on Azure. So there are different cloud networks, and now there are also like on-prem data centers, right? So you, as a particular networking admin, it becomes challenge at scale to provide like connectivity with low latency up to these applications that are globally scattered. So that is one of the challenge we wanted to solve with the ZTNA connector. And the next one is the sheer networking complexity. So let's say if you have like 5 or 6 VPCs or like 5 to 10 data centers, and for these particular like this amount of network, like you'll have to go and spin up IPsec tunnels, you'll have to do bandwidth management, you'll have to take care of the like the IP address management, and also you will have to take care of like BGP, and also if a particular tunnel goes down, the management of the network. So all of these is a pretty intensive task and costs our networking team a lot of money and a lot of operational overhead. So that is the second problem we wanted to solve. And the third one was, of course, the overlap network. We see that, like again, going forward, like every M&A kind of introduces an overlap, and also sometimes when you migrate from on-prem to cloud, there is a bit of an overlap. Or like as you expand on your organization, like because of lack of RFC 1918 IPs, there is an overlap. So all of these are challenges that customers face, and they want a solution. They want a cloud native solution with a very minimal operational overhead to handle this overlap network. And that is yet another problem that ZTNA connector can help you with. So now, what is this ZTNA connector? It is a VM that we provide. We provide this VM in a lot of form factors. We support all cloud native, and we also support pretty much every on-prem form factor that is out there. So you can deploy this VM in your infrastructure subnet. The VM automatically forms a tunnel into Prisma Access. The VM automatically discovers the applications that are there. So again, like we have two mechanisms of discovery. One is your cloud native discovery. So what this entails is like we integrate with cloud providers like AWS, where as a user you just give us a read only permission into your cloud assets, and we look at that particular infrastructure and we figure out what are the applications you're running. And like this way we even help you with your shadow IT applications, because there are applications maybe even you don't know that is there in your infrastructure, but we will be like able to discover and onboard specifically that application and not an entire subnet. So that is that one more thing, like this VM can go and discover. And once we have discovered these applications, you can onboard these applications to ZTNA connector. Once these applications are onboarded to ZTNA connector, like the ZTNA connector can, from a networking perspective, it will automatically form the tunnels to Prisma Access, and also it will automatically establish the routing constructs between Prisma Access and the connector itself. And once this is set up, you will be able to seamlessly access your private apps. So we have taken away the complexity of spinning up tunnels, managing the network, managing the bandwidth, and we have replaced it with just spinning up a VM, and the rest of it is a completely managed model where we take care of all of that. So that is, I think, one big change, or like one big difference when you look at our other private connectivity options, where there is some bit of user work that is required. Again, like there are customers who like that. There are customers who want to manage their own network, want to manage their own BGP. So for them, we have the service connections, but with the ZTNA connector, we give a dramatically simpler option to connect to private apps. And goes without saying, every one of Prisma Access products is like top on security. We have the same user ID, device ID, app ID. In fact, by end of this month, by end of next month, sorry, that ZTNA connector can start acting as a user ID redistribution agent, and it comes with a full security suite, again for the customer, included with the ZTNA connector pricing packages. Again, now let's look at some of the key competitions, like with our latest enhancements on the ZTNA connector, where we stand with one of our key competitor. So ZTNA connector is the only connector out there that can give you user ID in the logs and also can do user ID redistribution. With pretty much every connector out there, because there is an element of source NATing involved, the user ID or the user's IP information is lost. The ZTNA connector, again, we are like the first connector out there that can do cloud native application discovery. So for most of our competing products, the application discovery runs in the flavor like, hey, you need to allow or whitelist a particular subnet for a specific period of time, and based on that we can discover. But for ZTNA connector, we can discover your applications even before the very first access. So this is preventive, this is more secure, and this is more sophisticated. And we also do day end discovery, like for applications that are not discovered in a day zero basis. We also do a day end discovery, which is similar to what the competitors do. So we do day zero and day end. And we will be supporting one of the most advanced unmanaged devices soon, that's your enterprise browsers. So we will be supporting enterprise browsers in by June. And also we provide agentless access today, and we also have a secure agentless access with the capabilities of, in the future we will extend it to URL rewriting. So that is better than any of the agentless access our competitor provides, which is primarily based on a reverse proxy. And again, from a security stack, we have a inline malware detection, we have DNS security, we have internal DDoS protection, which comes with again a cloud scale. With our competitor, it's like mostly for private apps, it's a pass through. So there is a direct tunnel between the user to the application, like, or the connector. So there is not much security stack involved there. And we also have plans to have intelligent diagnostics. So let's say you have your connectors, maybe the connector goes down, or like maybe there's a path congestion, or maybe there is a particular applications is throughput is very high. So all of that we will be able to intelligently assess and give you a remediation. For that we will be partnering with our AIOps solution to do that. Any questions so far? All right, let's
I see
continue.
we have four in the chat.
Okay, let me just answer the questions in the chat.
You can either answer it right now, Uttam, or Terry or someone can also type it in the chat box, whatever
Yeah,
works.
I'm answering the questions, and if I think there are some questions I can mark
Okay,
it
perfect.
answer live. Go ahead. Yeah.
All right. Now a quick this thing on the ZTNA connector journey again. Like going forward, like this will be our primary private application mode. So in fact, ZTNA connector would be the default for all private apps. And if there are any use cases with ZTNA connector we cannot solve, then we go via the path of service connections. So with that, some of the things that we have done over the last year, now we support wildcards, we support IP subnets, you can access individual IPs, or if you don't know about the infrastructure, then in that particular case, we will like also be we will be supporting wildcards across n number of data centers. All you can do is like just probably do star dot star, and we will be able to discover the applications that are there. Again, not literally star dot star, but at some specific TLD is what we will need. And the next one is we started supporting Anycast architecture. With this Anycast architecture for specifically globally distributed applications. So let's say one particular FQDN server is residing globally. We can take the user's traffic to the closest application server, and in that way, the users will get better connectivity metrics. And we have significantly enhanced our scale. Like I will just come to the scale numbers. We have almost 4x our scale compared to the initial launch, and we will be again investing more resources in making it true cloud scale fashion. Now coming to a bit of scale, I think out there our connector does the highest throughput. We do 1 gig, and like the total number of connectors per group we cap it to 4. We have also supported that, like increase the support for total number of FQDNs per tenant to 4096, and like the total number of connectors per tenant we do 200. So again, I'm not sure like how many of you are aware of the initial numbers, but compared to the numbers 1 year ago, some of these numbers are a 4x improvement. All right. And again, just from a reiteration perspective, like in in 5.2, we have targets to like push these scale boundaries much further. We want to go up to 10,000 applications. We want to do like 512 IP subnets in a particular group. And we also want to increase the connector numbers to 400, which, by the way, is highest when it comes to the app connector markets. Quick question on the licensing. Again, like we always get questions on licensing. What am I entitled to? Like, is there any changes? What is planned? For the first 6 months, again, like 5.0 onwards, we made a change in the licensing. Now, like in the essential tier, you get around 8 connectors, and in the free tier you get 2, premium you get 40, and advanced you get unlimited number of connectors. And on top of that, we will also be giving you like IP subnet functionality in all the tiers. However, in free and essential tiers, we will be limiting the number of IP subnets you can advertise. Number of FQDNs, that kind of remains the same. In the free tier we support 20, essential we support 100, premium we support 300, and advanced we support unlimited. So, yep, this is a quick intro of all the things we have done over the last year: licensing, product positioning versus competition. Now, I would hand it over to Terry to do a bit of the product demo and also go into the nitty gritty of how you can use some of the latest features that we have released out there. Over to you, Terry.
Cool. Thank you, Udam. Hey everyone, my name is Terry Zhang. I'm from Prisma SSE Technical Marketing Engineer team. Today I'm going to show you 2 demos. So one demo is a sneaky peek of the all the updates Udam just covered. Then I will also provide you a demo to show you how the API works with the ZTNA connector. Okay. Now let's jump into the demo. In SCM, I'm going to workflow ZTNA connector and the ZT connector groups. I have 3 connector groups in GCP Azure, and I also onboarded them as FQDN and IP subnet group type. You will notice I have the DNS anycast IP assigned to each of the connector group. This will be used for wildcard application discovery and onboarding. Now I'm going to navigate to the connectors. I have connectors deployed globally on both Azure and GCP, and each of the connector will be assigned with a /27 connector IP block. The ZTT service IP will also be provisioned, and you will be able to monitor that in this page. Now let's navigate to application targets. As you can see, we support for single application targets be assigned to multiple connector groups. And also, Anycast IP will be assigned to each of the application. So with the overlapped FQDN deployed in multiple data center, will be able to access that via the Anycast IP plus supports. This is a quick demo to show you how we can create a new targets and assign that across multiple connector group. And we can define the ports based on port range. Okay. We are also supporting the wildcard targets across multiple connector group, as we also assigned the Anycast IP to the connector group. In the coming releases, we will support a more robust application discovery method. In this demo, the discovered targets as well as the IP subnet application targets was already supported in the previous release.
So now we're moving to the API demo.
The first, we're going to create the service account. Then we'll have two scripts to help you to collect the deployment status and also to deploy a connector group and a connector. Last but not least, we're going to use the API call to delete the connector group and the connector we created. First, let's log into SCM, going to Identity and Access. On the targeted tenant, click Add Identity. Then, from the drop-down, select the service account. Give the service account a name. Click Next. Then it will generate the credentials and the client secret. Download the CSV file. In the last step, we are going to assign roles to this service account. We are going to assign this service account as super user to all apps and the services. Once submit, we will see the service account is created, is a service account type. In the next demo, we're going to use scripts to retrieve deployment status. So here's the high level of the scripts overview. Please note you should already retrieve the service account information in the CSV file. Replace the client ID, client secret, and the scope TSG ID with your deployment. Next, we are going to retrieve the bearer token. One thing we need to make sure when you are retrieving the token, please configure the headers and specify the plan region with your CDL region. For example, my tenant is on United States, so my region should be Americas. This script basically does a couple of things. It collects all the connector group, connectors, as well as all the application associated with the deployment. All the demo scripts are uploaded to a shared folder, so you can review the details later. Next, we're going to execute the scripts. As you can see, it starts to collecting all the deployment information. To verify that, log into SCM, navigate to ZTNA Connector configuration workflows, and verify the connector groups, app targets are showing as what we are collecting from the API calls. In the third step, we are going to deploy a connector group and a connector. So similarly, you need to replace the client ID and the secrets with the service account info. Also specify the API region to your tenant CDL region. In this script, we're going to create the connector group, create the FQDN connector. Then we will use the API calls to retrieve the deployment secrets and the token. So you can use that to activate and onboard the connector VMs in your data center or your cloud. So we're going to execute this script. As you can see, the FQDN group, the FQDN connectors are created. Then we put a timer for 10 seconds for the backend to fully sync, and we are displaying the keys and the secrets in a table. To verify that, refresh the SCM, and you should be able to see the connector group and the connectors we just created via APIs. And in the connector, under the action, you can retrieve the key and the secret the same way as we derived from the API calls. Last, we are going to use API calls to delete the connector group and the connectors. First, we are using the first script to retrieve all the deployment status in order to obtain the OID of the targeted connector and the connector group. So as you can see here, we already retrieved the API demos connector and the connector groups OID. Then we are going to switch to Postman to make one-off API calls as a best practice to delete the connector and the connector group in the reverse order as how it's created. First, in the Postman, we are going to generate the bearer token the same way with the service account info. Also, you need to make sure the headers you are configured with the correct Palo Alto regions, which is the CDL regions. Then copy the OID of the connector first and execute the delete connector API, replace the connector OID and as you can see, the connector is deleted. Then we're going to copy the connector group OID and use the delete connector group API call to delete the connector group. As you can see, I might have a wrong token, so I need to assign the right token, and the connector group now is deleted successfully. I will rerun the script. It should refresh with the latest deployment status. As you can see, the API demo connector group and the connectors are now deleted. So I have my environment cleaned up in the original status. Now we're going to navigate back to SCM and verify UI also got the update. As you can see, the API demo connector group and the connectors are deleted. Thanks for watching the demo. Here are some useful resources. Please make sure always check pan.dev for the latest API documentations and the demos.